Hello everyone, welcome back to our channel. So in the previous video, we have seen one problem on metric space. Today we are going to see the another problem. From this problem only, we are going to get a node point. So please be careful. So don't skip the video. Please do watch until it's completed. Let x is equals to r square and define d of x comma y is equals to under root x1 minus x2 whole square plus y1 minus y2 whole square for all x comma y, where x is equals to x1 comma x2 and y is equals to y1 comma y2. First, when you see a problem, try to write down what are the given parts and what we need to prove, what we need to solve. The forgiven delta is d of x comma y is equals to under root x1 minus x2 whole square plus y1 minus y2 whole square. And here the x comma y belongs to real numbers. And x is equals to x1 comma x2 and y is equals to y1 comma y2. Now we need to show that whether these x is equals to r square is a metric space or not. So we know in order to be a metric space, it should satisfy the d of x comma y should satisfy the four conditions. So in this today's problem, I am not going to explain any example because it is very clear from the previous two videos, I think, and it is very clear and concise way. So it is a waste of time by explaining the examples in this video also. So the first property is d of x comma y is greater than or equals to 0. As it is a root and a square, therefore the d of x comma y is greater than 0, greater than or equals to 0. Therefore x1 minus x2 whole square plus y1 minus y2 whole square is greater than or equals to 0. First condition satisfied. And second, which is null property, d of x comma y is equals to 0 if x is equals to y. We have x is equals to x1 comma x2. Therefore y is equals to y1 comma y2. So take x1 d of x comma y, therefore under root x1 minus x2 whole square plus y1 minus y2 whole square is equals to 0. Therefore if root is sent to the outside, then x1 minus x2 whole square plus y1 minus y2 whole square becomes 0. And we can take x1 minus x2 whole square is equals to 0 and y1 minus y2 whole square is equals to 0. From this we can write x1 is equals to x2 and y1 is equals to y2. So by taking d of x comma y is equals to 0, we have prove that x is equals to y, which is x1 is equals to x2 and y1 is equals to y2. So the second property is also satisfied. Now the third property. The third property is symmetric property. D of x comma y should be equals to d of y comma x. Just in the place of x, substitute y. In the place of y, substitute x. Therefore, d of x comma y is equals to under root x1 minus x2 whole square plus y1 minus y2 whole square. In the place of x1, we need to substitute y1. y1 minus y2 whole square plus x1 minus x2 whole square, which is nothing but this is d of x comma y. In the place of y1, in the place of x1, I put it y1 and in the place of x2, I put it y2. Just interchanging the x to y and y to x. So which is nothing but I can write this equation if you compare these both, the first one and the second one. If this is expressed as d of x comma y, I can express the equation 2 as d of y comma x. Therefore, d of x comma y is equals to d of y comma x. Hence, the third condition is also proved. Now, the fourth condition, triangular inequality property, d of x comma y is less than or equals to d of x comma r plus d of r comma y. Here we have d of x comma y is equals to x1 minus x2 whole square plus y1 minus y2 whole square. Here we need to add any of the real number to it. We need to add and subtract. So I am taking here z1. Therefore x1 minus x2 plus z1 and minus z1 whole square plus y1 minus y2 plus z2 and minus z2 whole square. Can we further divide this term like previous problems? No, right? Because here the root is there and we have the square terms, which is, if we take this as a and this as b, which is a plus b whole square terms. So we cannot divide this equation into further so that we get d of x comma r plus d of r comma y. మనము దీన్ని తీసుకుంటే గనక ముందటి ప్రాబ్లమ్స్ లాగా మనం వచ్చిన ఈక్వేషన్ని ఇలా రాయలేము. We cannot divide further. So for this, the d of x comma y, this one, does not satisfies the inequality property from metric space. ఇదనేది ట్రూ కాదు. It is not satisfying. So that's why this problem is not a metric space. X is equals to r square, d of x comma y is not a metric space. And from this problem, I am taking a note that d of x to the power of n minus y to the power of n, if n is odd, then it will be a metric space. If n is even, it is not a metric space. Because this is the example. If it is even, we cannot divide this further and we can write it in the way of d of x comma r plus d of r comma y. If it is odd, we can easily write as before problems. Because in the before problem, the power is 1. So we can easily divide it. So this is the note point which can be asked in competitive exams or in your internals. So please make a note of it. D of x to the power of n minus y to the power of n. If n is odd, then it is a metric space. If n is even, it is not a metric space. Simply by seeing d of x comma y, you can say that whether it is a metric space or a not metric space. Thank you all. Happy learning to you. In the further videos, we are going to see the important definitions so that based on those definitions only, the theorems can be solved. Thank you all.